Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray and in this video we'll be looking at the logarithmic function. So let's get started. Okay, so let's first look at the definition of logarithmic function. Now, logarithmic functions are nothing but another way of looking at the exponential function. It is just another way of how we are looking at the exponential function. Okay, so remember what the exponential function was. Y is equal to a to the power x, where a was greater than 0, a is not equal to 1, and x belongs to R. Also, the range of this function is y is greater than 0. This is the exponential function. Logarithmic function is just another way of looking at this function. So I am writing it down here first. Another way of writing the same thing is log y to the base a is equal to x. So instead of writing it like this, I am writing it like this, and what this means is, this means that it means that y is equal to a to the power x. Because it is the same thing written in a different way, the conditions will apply as it is. So the conditions are a is greater than 0, a is not equal to 1, x belongs to R, and y is greater than 0. The conditions are the same. Now, this is a function, but remember that when writing a function, we take x as the independent variable and make y the dependent variable. So what we do now is write it in this way such that we get log x to the base a is equal to y. So we make the independent variable x and the dependent variable y, and we get the logarithmic function. Now the conditions are that a is greater than 0, a is not equal to 1, but since we have interchanged x and y, here x and y will also be interchanged, so we get y belongs to R and x is greater than 0. This gives us the logarithmic function. This is the definition. And it is read as log x to the base a is equal to y, and it means that x is equal to a to the power y. Okay, now we see that a has to be greater than 0, a is not equal to 1, and x has to be greater than 0. So the domain of logarithmic function is x is greater than 0, that is x belongs to the set open interval 0 to infinity. A is greater than 0, a is not equal to 1, a is known as the base. So these conditions apply to the base. Also, the range of the logarithmic function is y belongs to the set of real numbers, so all real numbers, that is y belongs to minus infinity to infinity. Also, the exponential function and logarithmic function are inverse of each other. That is because we have basically written exponential function in another way and then interchanged x and y to get the logarithmic function. So we are basically interchanging the roles of x and y. That's why exponential and logarithmic functions are the inverse functions of each other. That's why the domain of the logarithmic function is the range of the exponential function, and the range of the logarithmic function is actually the domain of the exponential function. Okay, so as we have established that exponential and logarithmic functions are inverse functions, we can look at the graph of logarithmic function and see that the logarithmic function will be symmetric to the exponential function with respect to the line y is equal to x. Of course, there are two cases. Case 1 is when base is greater than 1. So the exponential curve is like this. The graph of the logarithmic function will be reflection of this with respect to y is equal to x, which will be this. So this is y is equal to log x to the base a. This is when the function is an increasing function, that is when a is greater than 1. Now when a is less than 1 but more than 0, that is a is greater than 0 and less than 1, the graph of the exponential function is like this. Line y is equal to x is this. The graph of the logarithmic function will be a reflection with respect to this line. So the graph of logarithmic function is this curve. This is a decreasing function when a is greater than 0 and less than 1. Now we see that the graph in both the cases, the y-axis is the vertical asymptote for the function. So y-axis, that is the line x is equal to 0, is a vertical asymptote of logarithmic function. If we look at the behavior of the graph, then when a is greater than 1, as x tends towards infinity, y tends to infinity. As x tends to 0 plus, y tends to minus infinity. In this case, when a is greater than 0 and less than 1, as x tends to infinity, y tends to minus infinity, and as x tends to 0 plus, y tends to infinity. The base of the logarithmic function can be any positive number other than 1, but there are a few numbers which are used extensively, like log x to the base 10 is known as the common log because to the base 10 is used very widely. Also, log x to the base e is known as the natural log or the Napier's log as well, and it is also written as ln x. Okay guys, so we looked at the logarithmic function in this video. I hope you liked the video, and if you did, hit the like button and subscribe to our channel. We'll be bringing more great videos like these. Thank you.